Today we'll go over equations that are parallel or perpendicular to an original equation. Parallel lines have the equal slopes. For parallel lines, slope of the first line will be equal to slope of the second line. For example, we want to find an equation that will pass through -4, -5 that is parallel to our y equals -1/2 x minus 3. Now, in order to be parallel, our slope of our first equation, the slope of our first equation, -1/2, needs to be the same of our new slope. So we were given a slope of 1/2, and we're going to use the slope of -1/2. Now, when we use the point, which was given, to find the equation of the new line, we will use the point and our new slope. To label these properly, this is our x1, -5 is our y1, so to show the first step of writing the equation, we have y minus y1 equals, let me fix this capital Y, the slope times x minus x1. So we are using the point slope formula because we are given a slope and we have a point that we are going through. Plugging in our values correctly, we have y minus a -5. A negative times negative makes it a positive. Equals our slope, which was -1/2, x, now minus a negative again will give us a positive 4. Let's fix that font a little bit. So we create the equation y plus 5 equals -1/2 x plus 4. To show this on the graph, we can find the location. Our -4, -5, -4, -5. And we can create our line using our slope of down 1/2. Down 1/2. We can use this as many times as we want to get whole values for our points. And we can create a line out of this. So using our point to start with, our -4, 5, and then our slope to create more points to make creating the line easier, I have created the line to the equation. Example 2 wants us to find a line that passes through 4, 2 that is parallel to the x-axis. Our x-axis has an equation y equals 0. So we have a slope of 0 in this case. In order to find a line that is parallel to the x-axis, we simply need to say that y is equal to the y value that is given. So in this case, knowing that our y-intercept is 0, or I'm sorry, 0, 2, and our slope to the x-axis, our y equals 0 line, is 0, our equation will be y equals 2. When this happens, we create a line that goes at a height of 2. X can be any value. So it's a horizontal line that goes on forever in both directions. So in this case, here's our location for 0. As you can see, it goes through our horizontal line. Because it's horizontal, all of my y values are going to be 2. And to include 4, I'll start at 1. X value can be 2, 2. Next point could be 3, 2, 4, 2, and I could go on forever in both directions. We have a similar situation whenever a line is parallel to the y-axis. That means our equation would be x equals 0 for this situation. So then we would focus on setting it up to equal our x value, the 4. In this case, the y-intercept is going to not be available. It does not exist. Our slope, since it is going to be a vertical line as well, just like our y-axis, is undefined. Which I'll just write as UND for undefined. Our equation will still be x equals. But this time we'll use the x value of the point that we need to go through of 4. So what this means is I will go over to the x value 4, and I will have a straight vertical line that runs parallel with the y-axis. Vertical lines, the x value never changes. That's why we chose the 4 from the point. So in this case, doesn't matter what my y value is, my x value will always be 4. So with parallel lines to the y-axis, we will use x equals and whatever x value we need to go through. And a parallel line to the x-axis, we will use y equals whichever y value we need to go through. Perpendicular is a little bit different. Instead of using the same slope, we will use the opposite reciprocal of that slope. Now, our example is the same as earlier, but this time once it's perpendicular. So this time I'm going to take our slope, M1. Up here it states that perpendicular lines mean that the slopes multiplied together would equal -1. In order to do that, to multiply to have a negative, you have to have the opposite. So if we start off with -1/2, in order to have the -1 multiplied out, we have to multiply by a positive. So we know the new slope's value must be the opposite, positive. The reciprocal means that we are going to flip our fraction. We are going to take the 1 and switch it with the 2. So we have 2 over 1. We can simplify this to equal 2. The reason why this works, when you multiply fractions together, you multiply the top together and the bottom. 1 times 2 is 2. 2 times 1 is 2. And then 2 divided by 2 equals 1. So that's where the 1 comes in. And then a negative times a positive gives us the negative value. That's how we end up with negative 1 after multiplying our slopes. So after we solve this for our new slope, we can plug it into an equation. Now, considering that we have to include the point -4 and -5, we'll do the same thing as last time with our parallel, but this time we will use our perpendicular's new slope. We have y minus a -5, minus a negative is just positive. So y plus 5 equals our slope, which is now 2. And this will multiply the difference of x. And since it's minus a negative yet again, we have plus 4. So this is the same step as earlier for our parallel, but this time we did not use the parallel slope. We used the perpendicular, the opposite reciprocal. We could do the same thing on the graph. We go to -4, -5, place our point. Now this time, we go up 2 over 1. Almost went too far. So in this case, if you look at our two lines, you can tell that they will intersect each other at a very specific angle. That angle would be 90 degrees. Now, when comparing it to the x-axis, when we want to find a perpendicular line of the x-axis, almost wrote down the wrong variable. We need to remember that this means y equals 0. This has a slope of 0. So the perpendicular slope to our x-axis would be undefined. The opposite of a horizontal line, our x-axis, would be a vertical line. Our example would be our y-axis. So that means that our equation is going to be x equals. When we have a vertical line and we want it to go through a specific point, we have to use that point's x value. So in this case, we'll use x equals 4. So yet again, we can use all of our values, x values as 4, and then our y values can be anything because our x values will always be 4. Now with this vertical line yet again, we do not have a y-intercept. Since it's perpendicular to the x-axis, that means that it's going to be parallel to our y-axis, which means that they will never cross. Same concept works with our y-axis. Our y-axis has an equation of x equals 0. That means that the opposite from undefined slope would be a 0 slope, an equation that says y equals and the point y value that we want to go through. So with this, we actually have a y-intercept value of 0, 2. And our slope will be 0. The perpendicular situation of the same point is the reverse of the parallel of the same situation. 0, 2 is a location, 0 is a slope, and we have y equals 2 with the x-axis. And we have that same setup, 0, 2, 0 for a slope, y equals 2, for the y-axis. To fill out the rest, 0, 1, 2, 3. Our y value will always be 2. So with perpendicular, when dealing with the x-axis, our horizontal line, our new line will be undefined, a vertical line. When dealing with our y-axis, the vertical line, a slope of undefined, it will now be 0, a horizontal line. This is using the idea of opposite reciprocal, where when we multiply our two slopes together, they should equal -1. Opposite referring to taking our symbol. If it's negative, we make it positive, and then vice versa. If it's positive, we make it negative. And then reciprocal means taking our fraction and flipping it to get 2 over 1, which is 2. When we have a whole number, if we started with the 2, we need to remember that 2, or any whole number, is that number over 1. So if we had the reciprocal of a whole number, it would be that whole number at the bottom of the fraction under 1.